Hi and welcome back to part 9 of this motorbike rigging tutorial series for Blender. In the last part we added our character onto our motorbike so that all of our hand and foot targets follow correctly, and we're going to now add in controls so that when we move our root bone, our wheels are going to rotate correctly. This is actually relatively simple to do, but it does come with a fairly big caveat, which is something that we talked about in one of the earlier parts when we were setting up the tilt, and that's what's called passing that U-turn test, which we'll get to in a moment. So what we're going to do is we're going to go onto our bike rig and we're going to look at a mechanical layer. Let's turn off our rider for the moment and let's just go into local view on this. So the bones that we're going to be focusing on are our mechanical wheels for both the front and the back. So let's start with our front one. So we're going to go to the bone in pose mode, and on the X rotation, which is going to be this one. So if I just rotate this in the X axis, that's the one that's going to turn our wheel. The first thing we need to do is change the mode from quaternion to XYZ Euler. Again, quaternion math is very complicated, and it basically, as I says, no gimbal lock. I'm not going to get into exactly what it means, but for the purposes of this, you just need to know that you need to change it to XYZ Euler. And what we're going to do is we're going to add a driver to the X rotation, and you're going to immediately get the driver property. If you've never used drivers before, at the moment we've just copied and pasted values as drivers. For this, we're going to be actually setting up our own driver. Well, our object is going to be our bike rig and the bone is going to be the root. We're going to change this from X to Y location. And what we basically want to do is say that when we move this in the Y direction, and I've unhovered off of it, so it's gone, the driver's gone. Instead of opening it, I'm just going to split my window and open up the driver's editor. If I click back on XYZ Euler, and go to drivers, we can see that information's back. Now, so if I just grab this, that's not really doing much. It's starting to work, but not correctly. What we want to do is change this from world space to transform space, so that even if so at the moment I can grab it and it's going to move. Even if I rotate it around and then grab it along its local Y, it's still going to move. I'm not going to dig into the mathematics of it, but the basic formula that we need to know is that our rotation is going to be the distance that we've travelled, so i.e. what's the location of our Y bone, or the Y location, sorry, of our root bone, divided by the radius of our wheel. Now we do know the radius because we can just go into edit mode, and on our bones, our radius is going to be the height, or the Z value of our bone. So I'm just going to copy this, just cutting off the units. Let's go back into pose mode, and our variable, so this is called VAR, so that's fine. So it's VAR, so our variable, and at the moment it's set to scripted expression, which is what we want, and at the moment it's just +0. Well, we want to divide by the radius, so I can just paste that in. Press enter, update dependencies, and now if I move this, well, it's going backwards, so we actually need this to be minus variable divided by the radius. And now if I move this, our wheel is rotating correctly. This works absolutely fine, and we can also then just rotate this around. We can grab it in the local axis and it's still going to work. Let's do the same for the back wheel. So let's go into edit mode and get our Z data. Going to change this from quaternion to XYZ. Add a driver. Our object is our bike rig and our bone is our root in the Y location in transform space, and our expression is the negative variable divided by the radius. Update dependencies, and now our wheels are going to rotate correctly. We can drift, we can move this around, this still works even with our steering. So if I move this over and then move this, and this is one of the reasons why we set that deform bone to be local with parent. So you can see this bone is still rotating, the mechanical bone is still facing perfectly straight, but this is still rotating perfectly fine even while tilted. The problem that you encounter, as I said earlier, is that this works perfectly fine. If I just maximise my view, this works perfectly fine while we're travelling forwards. But if I rotate my bike backwards, at this point we're going to break the tilting anyway. So let's actually maybe just turn off the tilt strength to 0. I mean, it's now going to lay the bike flat on its side. But now if I grab it, even though the bike is supposed to be moving forwards, the wheels are moving backwards. And that is something that we're going to solve in the final part of this tutorial series, which is animating along a path. So this setup, where you just take the Y location in transform space of the root and divide it by the radius of your wheel, is going to work perfectly fine for simple animations where we just want to have our bike always moving forwards. If we want to do something more complex, we're going to need to do that with a path. And that is what we're going to do in our final part of this tutorial series. Join me there. Thanks for watching.